Hello children, today we are going to start with chapter Light, Reflection and Refraction. In this video, we will discuss topic refraction of light. For reflection of light, you can go to my previous video. Link is given in the description box. What is refraction? Refraction is change in direction of light passing from one transparent medium to another. If ray of light is passing from air to solid glass slab, its path is changing. That change of path is termed as refraction. Speed of light in air is 3 into 10 raised to power 8 meter per second. Here are some examples of refraction. Bottom of swimming pool appears higher, and a pencil, when it is partially immersed in water, its position seems different. It seems like it is not straight, it is having a bent shape. Lemon, when it is placed in glass tumbler, appears bigger in size, and letters of books appears to be raised up when seen through a glass slab. Similarly, if you will keep a coin in glass, it seems raised up. Then you have refraction through a glass slab. This is diagram here. It is a glass slab. This is ray of light which is coming through it. It is called incident ray. Light which is falling on it is called incident ray. Incident ray is making angle of incidence I with the normal. Now see, it should be the path. It should go like this, straight line, but it is changing its position. It is changing its path. That change in path is called refraction of light. This is refracted ray. This refracted ray is making angle of refraction with the surface, right? That is called angle of refraction. We know angle of incidence is equal to angle of refraction. In this case, we are having Snell's rule. Sin I upon sin R is constant quantity. Then this ray, when it is passing from glass slab to again air, it is again changing its path. It is moving away from the normal. Ray of light, when incident from air to glass slab, it is going towards the normal, means rarer to denser medium, it is moving towards the normal, and from denser to rarer medium, it is moving away from the normal. This is called refraction of light. The ray which is emerging out is called emergent ray. Then we have laws of refraction. In laws of refraction, first law is incident ray, refracted ray, and normals to the interference of two transparent medium at the point of incidence all lies in the same plane. Then the ratio of sin I upon sin R is constant. It is also known as Snell's law. Then refractive index. This is ratio of speed of light in given pair of mediums. Like you are having air and you are having another medium, right? So speed of light in medium 1 by speed of light in medium 2 is called refractive index of medium 2 with respect to medium 1. It is called N21. It is equal to speed of light in medium 1 by speed of light in medium 2. Its opposite is also true. N12 is equal to speed of light in medium 2 by speed of light in medium 1. Then we have absolute refractive index. When you are comparing refractive index of medium with respect to vacuum or air, it is called absolute refractive index. Absolute refractive index is equal to speed speed of light upon V, that is in another medium. Refractive index of diamond is highest. Its value is 2.42. Then we have optically denser medium and optically rarer medium. Optically denser medium is medium which is having high value of refractive index, and the another which is having lower value of refractive index is called optically rarer medium. If ray of light travels from optically denser medium to optically rarer medium, it bends away from the normal. You can see here It is incident ray, it is moving away from the normal. When a ray of light is moving from rarer to denser medium, it is moving towards the normal. We have two types of spherical lenses, concave and convex. Concave lens is this. It is diverging lens. It is thick from the corners and thin from the center. It is diverging. Then concave lens, thin from the corners, thick at the center. It is converging. Then you have rules for image formation by concave lens. These rules are similar as we have discussed in case of mirrors. This is a ray of light which is coming parallel to the axis. After striking with the central part of this lens, it is bending. It is changing its direction. If you will extrapolate, it will pass from the focus. As we know, the ray of light which is coming parallel to the lens will change its path and pass through the focus. A ray of light which appears to meet at the focus will emerge parallel to the principal axis. The ray of light, this is coming from this direction. If you will extrapolate, it appears to pass through the focus. It will become parallel to the axis. A ray of light passing through optical center will pass through it without any deviation, like this. For making ray diagrams, we know the three rules we have to follow. Now we can make the ray diagrams. First is when object is at infinity. Object is at infinity. These rays are bending. In this direction, their distance is increasing. So we have to extrapolate on the backward side. They will meet at focus. So image will be formed at focus. When object is at infinity, image is at focus. Nature will be its virtual and direct, its size is point size. When object is between infinity and optical center, object is between infinity and optical center, object is kept here, then nature of image will be virtual and erect and its size will be diminished. It is smaller than the size of object. So what you have to do, first ray from the head of this object will go parallel to the principal axis, and after that it will emerge out like this, and you have to extrapolate it and it will pass through focus. Second ray, it is coming from this optical center. It will pass without showing any deviation. These two rays will collide with each other at this point and they will make this image A dash B dash. So two rays we have drawn. First is parallel to the principal axis. It is passing through focus. Then second ray, which is passing through optical center, will pass without showing any kind of deviation. So these two will combine at one point. This is A dash B dash. This is image which is virtual and erect. Then rules for image formation by convex lens. Rules will be similar. First ray which is coming parallel to the principal axis will pass through focus on the another side of object. Then a ray of light passing through focus will emerge parallel to principal axis after refraction. This is passing through focus. So after image formation, this will, after showing refraction, it will change its path and it will become parallel to the principal axis. A ray of light passing through optical center will pass through it without showing any kind of deviation. Then these are diagrams. First is when object is at infinity, rays are coming parallel to the principal axis and they will combine at focus. The point where these rays will meet will be image. Image is very small. You can see it as point in size and its position is at F2 and it is real and inverted image. When object is buoyancy, first ray which is coming from the head of this object is coming parallel to the principal axis and it is passing through focus. Second ray, which is passing through optical center, will pass through it. As such, these two rays will combine at this point. Image is real and inverted, and its size is smaller than the size of object. Then when object is at C1, this is object is at C1, you can see first ray, which is coming parallel to the principal axis, will pass through focus. Second, which is passing through optical center, will pass through it as such without showing any deviation. Image will be formed at again C. It is C2, and this image is inverted and it is of same size. Now again, object is kept between F1 and C1. So what we are doing? We are shifting the size of object from infinity to beyond C, then between F and C, then F, and between F and O. These are the positions of object, and you have to see that image will be formed like it is moving away from focus to infinity. This is when object is between F1 and C1. Object is between F1 and C1. First ray coming parallel to the principal axis. It is bending and passing through focus. Second ray, which is passing through optical center. It will pass through it as such without showing any kind of deviation. So this is image formed. This is larger in size, enlarged image, and it is real and inverted. When object is at F1, when object is at focus, image will be formed at infinity. This is ray parallel to the principal axis that is passing through focus. Second ray, which is passing through optical center, will pass through it as such without showing any deviation. These true rays will never meet. You can see the object images will be formed only at infinity. When object is between F1 and O, then first ray parallel to the principal axis, it is passing through focus. Second ray, which is passing through optical center, will pass through it as such without showing any deviation. These two rays, you can see that distance between them is increasing in this path. So they have to meet backward. These will join only after extrapolation, and you can find that image will be virtual and direct, and it is bigger in size, enlarged image you can see. Then we have lens formula. In lens formula, we are using terms U, V and F. U is distance of object from optical center, V is distance of image from optical center, and we are having F, that is focal length. This is focal length, distance of focus from optical center. Then H is height of object, H dash is height of image. In lens formula, we are having 1 upon V minus 1 upon U is equal to 1 upon F. By using this formula, we can solve numericals that we will discuss in a separate video. Here is formula of magnification. Magnification is equal to height of image by height of object, that is H dash upon H. Magnification is equal to V upon U is equal to H dash upon H. Then we have power of lens. Power of lens is inverse of focal length. Means bigger is focal length, lesser will be power. Its value will be given in unit diopter. Diopter is inverse of meter. Thank you.